Hi, today I will talk about, this is a problem given to grad students at the University of Maryland. I will talk about the solution to this problem. Okay, let's get straight into the problem. Eve, we know, is a evil character in our story. Eve got the RSA public modulus of Bob. She wants to factor n and obtain the prime factors p and q. So I just wanted to quickly explain some notations here. So this is the story. N is the public RSA modulus. It's known to everybody. It's public. P and Q are prime factors that are kept secret. No one knows other than the person generated it. Okay. The question is asking us to solve this RSA problem. Given n, it is asking us to find the p and the q, which is very difficult to do in general. But we are given additional information in this problem. Somehow, Eve managed to obtain the distance between the two primes. So maybe she planted a virus or malware or something like that, or there was some limitation in the way the prime numbers are generated. So she was able to predict the distance between the prime numbers. So, or that's what we are saying here. See here, R is P minus Q. That means the absolute distance between P and the Q is R. So we are given that. All right. What is the problem now? The problem is to write an equation using variables P, R, and N in this particular format. For example, 3p square minus 2rp plus 9n equal to 0. How do we do that? Well, we are given R is equal to P minus Q. That means we can write either P or Q in terms of R. That's not a problem. So we can get it going now. So I'll just write the high-level idea here, and then we will take it from there. Okay, so let's take R as Q minus P. It doesn't matter because it's absolute value anyways. Now we can rewrite our above equation. What is Q? Q is, from here we can write Q is equal to R plus P. That means we can rewrite our N as P times R plus P, which means we can just rewrite it like P square, right? Which is nothing but, plus PR minus N equal to 0. So this is a quadratic equation. We know the value of N and R, we don't know P. So we have to now solve that. I guess the next part of the problem is to solve this equation to find the values P and Q. Okay, let's see what are the values they gave us. So they gave N and R. So we do know N and R. So we know N and we know R. And this is a beautiful quadratic equation that we are all familiar with. So how do we solve a quadratic equation? We know how to solve a quadratic equation. If we have an equation like ax square plus bx plus c is equal to 0, the roots are minus b plus r minus square root of b square minus 4ac by 2a, something like that. We do know that part. This is one root, and another root is, let me call this x1. Another root is minus. The same thing, just minus b minus square root of b square minus b square minus 4ac by 2a. So we do know how to solve quadratic equations. So in this case, our a is 1. If you look at the quadratic equation above, like this, a is 1. There's nothing there, and b is p, and c is b is r, c is minus n. So let me write it clearly. A is 1, b is r, c is minus n. So we can solve this to find p, and that's what I'm going to do. So I'm just going to write a simple Python program that will solve this problem for us. Okay, let's get it started now with the programming. Okay, so I just copied and pasted my R and N into this little editor, notepad editor. So I'll just make use of R and N first. I'll copy this into my, let's just make sure we copy everything. Okay, we have copied N, and we go to the terminal here. We start the Python now. I think we can clear my drawings, so we can just clear, and we will just start the Python and define our N. So we have our N. They also gave us the R. Okay, so R. So we got N and R. Now we need to find a way to solve quadratic equation. Python square root function won't work for large numbers like these. Luckily, there is a nice function that we can use. I'm not certifying the correctness of this function. It's up to you to check that, but I find this nice to work with. So I will just copy this and define the function as it is here. So we have the root function ready. Now we are ready to find the square roots and solve the prime p that we need to solve. So how do we solve p? P is nothing but minus r plus root. The square root is, we start with 2, square root of 2, square root of r square plus 4 times n. We'll make sure all of these are part of the division. Okay, so in Python we need to put 2 slashes for integer division. So this must be this one of the square roots, right? Minus r plus or minus. We don't have to do a minus because the primes in RSA are not negative numbers, so we can leave the minus part. Square root of r square plus 4n by 2a. That's what I wrote in my notes. Okay, so we should be able to print p. Such a long number. At least it's not even, so we can be confident it may be correct. At this point, we don't know exactly, but let's try to find the q also. What is q? Q is nothing but n by p. Okay. Now we can print q, which is another large number. We can check now whether n is equal to p times q. Let me print n. Okay, let me print p times q. We can now quickly compare whether they are equal or not. Well, it looks like they are equal. See here, all of these, and we can check. Yeah, it's all the same. So we now found out a way to factor our composite number n and able to find the prime factors p and q. So once you find the prime factors p and q, the problem is extremely simple, because let me show you how that works. So this is the RSA system, right? We know the public modulus n. We found out the p and the q. Therefore, we can easily solve and find the Euler's torsion function, because it's nothing but p minus 1 times q minus 1. Once we know pi of n, we know E. E is usually a constant, 65,537 or something like that. You know E, you know pi of n. If you do modular inverse, you can find D. Once you find D, you have found all of the private variables, pi of n, D, P, Q, and that's easy now. You can directly decrypt anything you wanted because you already found the D. So given a plain text message encrypted using RSA, all we need to do is just take the dth power, because we derive D from P and Q. Therefore, everything is solved. All the variables are solved. We can happily decrypt anything we wanted. So the main message is that if we can find the distance between the primes, even though we may not know the primes themselves, then we can immediately find the prime factors p and q. Just it's a simple quadratic equation problem, and then readily broken. It would be interesting to think about this problem and generalize it. If we don't know the distance, but we know some upper bound, how do we solve that? That would be an interesting problem to solve. Anyway, that's all I want to show you. Thank you very much.